What if everything you've ever known, every choice you've made, every moment you've lived is just one version of an infinite number of possibilities? Picture a reality where every decision branches off into a new universe, each one unfolding simultaneously like threads in a cosmic tapestry. This isn't science fiction, it's the mind-bending concept of the multiverse, a theory that suggests our universe might be just one of countless others, each with its own laws, its own history, and even its own version of you. The idea alone is enough to make your head spin, but what's even more fascinating is how these universes might interact or even collide with one another. Think about the implications for a moment. Somewhere out there, another version of you might be living a life that's almost identical to yours, or one that's wildly different. Maybe in another universe, dinosaurs never went extinct, or humanity discovered interstellar travel centuries ago. The possibilities are as endless as they are exhilarating. But how do these parallel realities connect? Could there be hidden doorways between them, or do they brush against each other in ways we can't even perceive? Scientists and theorists have spent decades unraveling these mysteries, and the theories they've uncovered are nothing short of extraordinary. Today, we're diving deep into 25 of the most compelling ideas about multiverse interactions, concepts that will challenge everything you thought you knew about reality. From quantum entanglement linking distant universes to cosmic collisions that could rewrite the laws of physics, these theories stretch the limits of our imagination. Some are backed by cutting-edge science, while others venture into the realm of pure speculation, but all of them will leave you questioning the very fabric of existence. So buckle up, because we're about to embark on a journey through the most awe-inspiring possibilities the multiverse has to offer. By the time we're done, you might never look at the universe or yourself the same way again. The first theory takes us straight to the heart of quantum mechanics, where the fabric of reality itself seems to bend and twist in ways that defy common sense. At the subatomic level, particles don't behave like tiny billiard balls with predictable paths. Instead, they exist in a haze of probabilities, a superposition where every possible outcome is real until the moment it's observed. This is where the idea of parallel worlds emerges. Imagine flipping a coin heads or tails, two possible outcomes. Quantum mechanics suggests that instead of settling on one result, the universe splits, creating two separate realities, one where the coin landed heads and another where it landed tails. But here's where it gets even stranger. These branching realities might not stay entirely separate. Quantum decoherence, the process that causes quantum superpositions to collapse into definite states, might also allow faint echoes of other universes to bleed into our own. Think of it like radio signals occasionally crossing frequencies, producing moments where static reveals distant transmissions. Some physicists believe this could explain bizarre quantum phenomena, like particles appearing to remember their past states or influencing each other instantaneously across vast distances. The famous double-slit experiment offers a tantalizing clue. When particles like electrons are fired one by one at a barrier with two slits, they don't just pass through one or the other. They act as if they pass through both simultaneously, creating an interference pattern that only makes sense if multiple possibilities coexist. Some interpretations suggest this interference could be the result of parallel worlds subtly interacting, their realities overlapping just enough to leave a mark. Could we ever detect these ghostly overlaps? Experiments probing quantum entanglement, where particles remain mysteriously linked no matter how far apart they are, hint that there's more to reality than meets the eye. If entanglement truly bridges parallel worlds, it might mean that the multiverse isn't just a collection of isolated bubbles, but a vast, interconnected web where boundaries are thinner than we ever imagined. Now, let's shift our gaze from the quantum realm to the vast cosmic ocean, where universes might not just exist side by side, but bump into each other like bubbles in a frothing sea. This is the inflationary multiverse theory, a breathtaking idea that suggests our universe isn't alone, but one of countless bubble universes constantly budding off from an eternally expanding cosmic foam. Picture a pot of boiling water where new bubbles form, rise, and sometimes merge, except here, each bubble is an entire reality with its own physics, its own history, and perhaps even its own version of space and time. What happens when these cosmic bubbles collide? The consequences could be written in the sky itself. Some researchers believe such collisions might leave scars, subtle imprints etched into the oldest light we can observe, the cosmic microwave background. Imagine finding a strange, circular pattern in the CMB, like a bruise from a long ago impact with another universe. These signatures, sometimes called cosmic bruises, could be the smoking gun proving we're not alone in the multiverse. One team even claimed to spot such a pattern in data from the Planck satellite, though the debate still rages on. But collisions might do more than leave marks, they could spark entirely new universes. In some models, when two bubble universes meet, the energy released could trigger a new Big Bang, birthing a fresh reality with its own laws. It's a cosmic domino effect. One universe brushing against another might set off a chain reaction of creation, with each collision spawning more bubbles in an endless cycle. And here's the wild part: if our universe was born this way, we might be living in the aftermath of a multiversal fender bender that occurred billions of years ago. The implications are staggering. If bubble collisions are real, they could rewrite our understanding of cosmology. Instead of a single, isolated Big Bang, we might be part of an infinite tree of universes, each branch a collision event that gave birth to new cosmic realms. It's a vision of reality where creation isn't a one-time event, but an ongoing process, a never-ending dance of universes touching, merging, and spawning new possibilities. Could we ever find concrete proof? Future telescopes mapping the cosmic microwave background in even greater detail might spot these telltale patterns, while advanced simulations help us predict what a multiversal collision should look like. Until then, the idea remains one of the most tantalizing and humbling theories in modern cosmology. After all, if we're just one bubble among countless others, what does that say about our place in the grand scheme of things? Black holes have always been cosmic enigmas, regions of space where gravity is so intense that not even light can escape. But what if these monstrous voids aren't just destructive forces? What if, hidden within their crushing depths, lies a gateway to another universe? This is the radical idea that some physicists take seriously, that black holes might be portals to entirely new realms of spacetime, their singularities acting as cosmic birthing chambers for fresh realities. Take Lee Smollen's provocative fecund universes theory. It suggests that every time a black hole forms, the extreme conditions inside its singularity could trigger the birth of an entirely new universe. Think of it like a cosmic Russian nesting doll. Each black hole in our universe might contain an infant cosmos within it, complete with its own laws of physics. Even wilder, that new universe could inherit slight variations from its parent, leading to a form of cosmic natural selection where universes fine-tune their own physics over countless generations. But how would information even cross between these universes? The answer might lie in the bizarre nature of singularities themselves. At the heart of a black hole, our understanding of physics breaks down, time and space become meaningless, and the fabric of reality is stretched beyond recognition. Some models propose that this extreme distortion could twist spacetime so severely that it tears open a bridge, a wormhole linking one universe to another. There's even speculation that the Hawking radiation emitted by black holes, traces of energy leaking out over eons, could carry encoded imprints of the universes they connect to. It's like finding a message in a bottle washed ashore, hinting at distant shores we can't see. If true, black holes wouldn't just be cosmic trash compactors, but inter-universe radios, faintly transmitting whispers from realities beyond our own. Of course, this all sounds like science fiction, but consider the math. Equations describing black hole singularities often produce solutions where space-time doesn't simply end but continues in another form. Even Einstein's theory of general relativity allows for the possibility of bridges between universes, known as Einstein-Rosen bridges. The catch: no one knows if these bridges would be stable enough to traverse, or if anything could survive the journey. What would happen if two black holes from different universes interacted? Simulations suggest their mergers could ripple across realities, leaving gravitational wave signatures that might one day be detectable. Imagine tuning our observatories to catch not just waves from colliding stars, but echoes from collisions between entire universes. The implications are staggering. If black holes truly are gateways, then every galaxy's core home to a supermassive black hole might be a dormant exit to another cosmos. Our universe could be nested inside a black hole from a parent universe, which itself sits inside another ad infinitum. It's a humbling thought. We might not just be in a multiverse, but part of an infinite lineage of universes, each birthed in the heart of darkness. Skeptics argue this is all speculative, and they're right. Without direct evidence, these ideas remain at the edge of physics, but that's what makes them thrilling. Whether black holes are cosmic killers or creators, they force us to rethink the very nature of existence. And if one day we uncover proof that they're bridges to elsewhere, well, the universe just got a whole lot bigger. What if the universe we perceive, with all its depth, its stars and galaxies stretching endlessly into space, is nothing more than an illusion, a breathtakingly detailed mirage projected from a flat, two-dimensional surface at the edge of reality? This is the core idea behind the holographic principle, a theory so radical it redefines the very nature of existence. Imagine the cosmos as a cosmic movie screen, with everything we experience, every touch, every breath, even the passage of time, encoded on a distant, flat boundary like data etched onto a gigantic DVD. The holographic principle was born from an unexpected place: black hole physics. When scientists calculated how much information a black hole could contain, they discovered something astonishing. The maximum amount of data wasn't proportional to its volume but to its surface area. It's as if every bit of information about objects falling into a black hole gets painted onto its event horizon like a celestial tattoo. Leonard Susskind and others realized this might not be unique to black holes. What if the entire universe works the same way? Now, here's where the multiverse comes in. If our universe is a hologram, its true source code exists on a distant 2D boundary. But what if other universes have their own boundaries, and these surfaces somehow touch or overlap? Interactions between these edges could create subtle resonances between realities, like ripples crossing paths in a pond. Some physicists speculate that quantum entanglement, the strange link between particles across vast distances, might actually be a shadow of deeper connections at this 2D level. Particles in our universe might appear to influence each other instantly because at the boundary they're not separate at all. Think of it like two movie projectors aimed at the same screen. If their images overlap, you'd see ghostly echoes of one film in the other. Similarly, if two holographic universes share a boundary, information might bleed between them. This could explain anomalies in cosmic radiation or peculiar quantum behaviors that defy conventional physics. There's even speculation that dark energy, the mysterious force accelerating the universe's expansion, could be a faint pressure from another universe's boundary pressing against ours. Could we ever find evidence for this? Some researchers suggest looking for strange correlations in the cosmic microwave background, patterns that shouldn't arise naturally in a single, isolated universe. Others propose experiments with ultra-precise quantum sensors to detect subtle noise that might hint at interference from another reality's holographic data. The implications are staggering. If true, the holographic principle wouldn't just connect universes, it would mean that reality, as we know it, is a kind of cosmic augmented reality, a shimmering projection from a deeper, stranger layer of existence. It's a humbling thought. Everything we are, everything we see, might just be the universe's way of reading its own reflection in a mirror we can't yet perceive. We've been searching for dark matter for decades, hunting an invisible substance that makes up most of the universe's mass but refuses to show itself. It doesn't emit light, absorb light, or interact with ordinary matter in any way we can detect except through gravity. Galaxies spin too fast to hold themselves together without some unseen force, and the cosmic web structure suggests something massive is weaving its threads. But what if dark matter isn't from our universe at all? What if it's the residue of another reality bleeding into ours? This theory flips the script on everything we thought we knew. Dark matter's ghostly behavior, its refusal to interact with light or ordinary particles, might not be a quirk of physics but a clue about its origin. If particles from a neighboring universe were seeping into ours, they'd operate under different rules, passing through our matter like shadows through a wall. Gravity, the one force we know acts across dimensions, would still tug on them, explaining why we only feel dark matter's pull and never its presence. Here's how it might work. Picture the multiverse as a stack of soap bubbles pressed together. The membranes between them aren't perfect barriers. Some particles could slip through, especially if other universes vibrate at frequencies just out of sync with ours. These leaked particles wouldn't align with our standard model, making them impossible to detect with conventional tools. Yet their mass would still warp space-time, bending the paths of stars and galaxies in ways that match our observations. Some physicists take this further, suggesting dark matter could be entire structures from parallel realities, cosmic fossils left behind when universes briefly brushed against each other. Imagine two sheets of paper lightly touching. Ink from one might transfer faint stains to the other. In the same way, clumps of matter from another universe might have left gravitational fingerprints in ours, invisible but undeniable. The implications are staggering. If dark matter is multiversal residue, it means we're not just surrounded by hidden particles, we're embedded in the echoes of other worlds. Future experiments could look for subtle patterns in dark matter's distribution, searching for unnatural clumps or flows that hint at an external source. Others propose hunting for rare particles that decay in ways our physics can't explain, potential refugees from a reality next door. Of course, skeptics argue this is speculative, and they're right. But that's what makes it thrilling. Whether or not dark matter hails from another universe, this theory forces us to rethink the boundaries of existence. After all, if the answer to one of cosmology's biggest mysteries lies beyond our universe, what else might be out there just out of reach? String theory paints a picture of reality far stranger than our everyday experience, suggests one where the universe isn't just 3 dimensions of space and 1 of time, but a sprawling cosmos with up to 11 dimensions, most of them curled up so tightly we never notice. At the heart of this idea are branes, short for membranes, vast dynamic surfaces that could stretch across higher dimensional space like sheets drifting through a cosmic breeze. Our entire universe might just be one of these branes, a 3-dimensional island floating in a realm beyond our perception. And if there are other branes out there, what happens when they collide? The answer might rewrite the history of everything. Some versions of string theory suggest that when 2 branes smash together, the energy released could ignite a big bang, an event so powerful it spawns an entirely new universe with its own laws of physics. Picture 2 sheets of paper fluttering in the wind, slowly drifting closer until bang, they touch, sending ripples across both surfaces. In that moment of contact, a universe like ours could be born. Even wilder, this might not be a one-time event. If branes oscillate through higher dimensional space, they could collide over and over, each crash resetting the cosmic clock and birthing a fresh reality. This cyclical model, known as the ekpyrotic universe, offers a startling alternative to the traditional Big Bang narrative. Instead of a single explosive beginning, our cosmos might be one chapter in an endless cycle of Brane collisions, each one wiping the slate clean and starting anew. Think of it like a cosmic heartbeat, with universes expanding, cooling, and then colliding again in a rhythm that plays out over unimaginable eons. The implications are profound. If this theory holds, the fundamental constants of our universe, the strength of gravity, the mass of an electron, even the speed of light, might not be arbitrary. They could be the result of how our brain crumpled and stretched during its last collision, like wrinkles in a bedsheet frozen into place. This might explain why our universe seems so finely tuned for life. If every collision tweaks the rules slightly, eventually one would produce a cosmos where stars, planets, and life itself can emerge. How could we ever test such an extraordinary idea? Some clues might lie in the cosmic microwave background. A Brane collision wouldn't just leave heat, it could imprint peculiar patterns like concentric circles of temperature variation as shockwaves ripple through the newborn universe. Others suggest hunting for gravitational waves from the very early universe, which might carry echoes of that primordial clash. Yet the most mind-bending possibility is that right now, unseen by us, another Brane could be drifting toward ours. If it hits, it wouldn't just create a new universe, it could erase ours in a burst of energy, only for the cycle to begin again. It's a humbling thought. Everything we know, every galaxy, every atom, might just be the aftermath of a collision we can't see, in dimensions we can't touch, waiting for the next cosmic reset. The many worlds interpretation flips our understanding of reality on its head, proposing that every quantum event doesn't just have one outcome. It spawns an entirely new universe to accommodate every possible result. Picture standing at a crossroads where every path you could take becomes real, each choice splitting the world into parallel versions where every what-if unfolds. But here's where it gets even stranger. These branching realities might not be entirely isolated. Quantum entanglement, the eerie link between particles across vast distances, could be threading these worlds together, creating faint but undeniable bridges between them. Take Schrödinger's famous cat, simultaneously alive and dead in its box until observed. In the many worlds view, the moment you open the box, the universe splits, one where the cat lives, another where it doesn't. Yet some theorists suggest these divergent realities might still whisper to each other through quantum connections. Imagine entangled particles as cosmic pen pals, their messages written in the language of probability, maintaining a subtle dialogue even as their worlds drift apart. This idea gains traction when you examine how particles behave in experiments. When two entangled particles are separated, measuring one instantly determines the state of the other, no matter how far apart they are. Einstein called this spooky action at a distance, but in the many worlds framework, it might not be spooky at all. Instead, the particles could be influencing each other across parallel realities, their fates intertwined not just in space but across the multiverse itself. It's as if every entangled pair is a stitch in the fabric of existence, binding worlds together in ways we're only beginning to glimpse. Could we ever detect these hidden connections? Some researchers propose looking for anomalies in quantum systems, tiny deviations from expected probabilities that might hint at interference from nearby universes. Others suggest that déjà vu or uncanny synchronicities could be fleeting moments where our timeline brushes against another, like two sheets of paper momentarily overlapping. The implications are staggering. If the many worlds interpretation is correct, and if these universes aren't entirely separate, then reality might be far more interconnected than we ever imagined. Every decision, every chance event could ripple not just through our lives but through countless versions of existence, woven together by quantum threads we can't yet see. It's a vision of the cosmos where nothing truly happens in isolation, and every possibility, no matter how distant, remains part of the same extraordinary tapestry. Time loops aren't just science fiction, they might be a fundamental feature of how universes interact with each other. Imagine a reality where the past isn't set in stone, where events can ripple backward through time, rewriting history in ways that defy logic. This is the heart of the Novikov self-consistency principle, a mind-bending idea that proposes any action taken in the past must align with the present that already exists. In other words, if you traveled back in time, you couldn't change history because your actions would have already been part of it. It's like trying to alter the plot of a book you're already reading. The story remains consistent, no matter how hard you try to rewrite it. But what if these time loops don't just play out in a single universe? What if they spill over into others, creating branching timelines where every possible outcome becomes real? Picture a universe where a time traveler prevents a catastrophe, only to spawn an alternate reality where the disaster still happened, untouched by their interference. The original timeline continues unchanged, while the new one splits off, carrying the traveler's alterations into a fresh version of history. This could mean that every attempt to change the past doesn't erase it, it just creates another thread in the multiverse's tapestry. The implications are staggering. If time loops can bridge universes, then paradoxes might not be dead ends but crossroads. Take the classic grandfather paradox. If you go back and prevent your grandfather from meeting your grandmother, how could you exist to make the trip? In a multiverse framework, the answer might be that you don't disappear, you simply shift into a timeline where your grandparents never met, while the original universe rolls on without you. It's not a contradiction, it's just another branch in an ever-expanding tree of possibilities. Some physicists speculate that these tangled timelines could leave detectable traces. If alternate histories brush against each other, subtle inconsistencies might emerge like memories that don't match recorded events or artifacts that seem out of place. Ever had a dream that felt eerily real, as if it belonged to someone else's life? Could those be fleeting glimpses of histories that almost were, or realities where different choices were made? The most fascinating part, time loops might not just connect alternate versions of our universe, they could link entirely different realities with their own laws of physics. Imagine a civilization in another universe discovering a way to send messages backward through time, only for those signals to cross into our cosmos as unexplained cosmic noise. We might already be surrounded by echoes of other timelines, whispering secrets we don't yet know how to hear. This isn't just theoretical playtime. Experiments with quantum particles have shown that observing a particle in the present can affect its state in the past, a phenomenon called retrocausality. If particles can blur the line between past and present, why not entire universes? The deeper we dig, the clearer it becomes. Time might not flow in one direction, and the multiverse could be far more interconnected than we ever dared to imagine. What if our universe isn't just a simulation, but one of countless others running on the same cosmic supercomputer? This isn't just wild speculation. Nick Bostrom's famous simulation hypothesis suggests that if advanced civilizations ever develop the power to create hyper-realistic simulations of their ancestors, the odds are overwhelming that we're living in one of those simulations rather than the original, base reality. But here's the twist: if our universe is a simulation, it might not be running alone. Other simulated realities could be operating on the same underlying hardware, like multiple apps open on a single device, and sometimes those apps might accidentally share data. Think about how computers work today. When two programs run simultaneously, they occasionally interfere with each other. A glitch in one might cause unexpected behavior in another. Now scale that up to universe-sized simulations. If multiple realities are processing on the same quantum substrate, tiny fluctuations in computational resources could create bizarre, seemingly impossible phenomena in our world. Particles might teleport unpredictably, or cosmic constants could momentarily flicker, as if the system is struggling to allocate enough processing power to keep everything running smoothly. Some theorists suggest this could explain certain quantum anomalies, Take the double-slit experiment where particles act as both waves and particles until observed. Could this be a sign of computational optimization, a way for the simulation to save resources by not rendering definite states until necessary? And what about déjà vu, those uncanny moments where reality feels like a loop? They might not be tricks of memory, but temporary sync-ups between parallel simulations, like two virtual environments briefly sharing cache data. Even more intriguing is the possibility of intentional crosstalk. Advanced beings running these simulations might design them to interact, creating shared events or synchronized phenomena across universes. Imagine two simulated worlds occasionally pinging each other, their histories momentarily aligning in ways that leave traces like identical patterns in cosmic background radiation, or recurring mathematical constants that appear too perfectly arranged to be random. Some researchers argue that if we ever discover a source code embedded in the fabric of physics, a set of equations too elegant or universal to be accidental, it could be evidence of deliberate design, a signature left by the programmers. Of course, skeptics dismiss this as untestable fantasy, but consider how we've already created isolated virtual worlds, video games with their own physics, NPCs with simulated consciousness. If humanity is on this trajectory, why wouldn't more advanced civilizations have perfected it? And if they have, the idea of multiple simulations occasionally glitching into each other isn't just plausible, it's almost inevitable. The implications are staggering. If our universe is sharing hardware with others, it means nothing is truly isolated. A cosmic reboot in one simulation might ripple into ours as a sudden change in physical laws. Mysterious phenomena like dark energy or quantum entanglement could be artifacts of deeper computational processes, hints that we're part of something far bigger and far weirder than we ever imagined. So the next time your phone glitches or déjà vu strikes, ask yourself, was that really a coincidence, or did another universe just brush up against ours? While black holes suck matter into their inescapable depths, their theoretical opposites, white holes, could be cosmic fire hoses blasting energy and matter outward with unstoppable force. Think of them as black holes running in reverse, where a black hole's gravity traps everything inside its event horizon. A white hole violently expels anything that dares to approach it, spewing material into space like a geyser from another dimension. These bizarre objects aren't just mathematical curiosities. Some scientists believe they could be the universe's backdoor, channels funneling matter and energy from other realities into ours. The math behind white holes emerges naturally from Einstein's equations, just like black holes do. But while we've observed black holes devouring stars and warping spacetime, white holes remain purely hypothetical. That hasn't stopped theorists from asking, if they exist, what would they look like? The answer might lie in some of the most energetic explosions ever recorded. Gamma-ray bursts, brief but unimaginably powerful flashes of high-energy radiation, have long puzzled astronomers. These eruptions release more energy in seconds than our sun will in its entire lifetime, yet their origins remain shrouded in mystery. Could some of them be the birth cries of white holes, rupturing into our universe from somewhere beyond? Here's how it might work. In a multiverse where black holes in one reality connect to white holes in another, a dying star collapsing into a black hole in universe A could trigger a white hole eruption in universe B. The matter swallowed by the black hole wouldn't vanish. It would resurface elsewhere in an explosive rebirth, like a cosmic magician's trick where nothing is ever truly destroyed, just transported. The sheer violence of these events would explain why gamma-ray bursts outshine entire galaxies, as the energy of a whole star's worth of material gets dumped into our cosmos in an instant. But there's a catch. White holes, by their very nature, should be unstable. Once matter starts pouring out, the outflow would likely collapse under its own gravity, forming a black hole and sealing the portal. This could explain why gamma-ray bursts are so fleeting. They're not just fireworks, but snapshots of multiversal tunnels slamming shut. Some models even suggest these brief openings could leave behind quantum scars, subtle disturbances in spacetime that linger long after the explosion fades. If we could detect these scars, they might serve as fingerprints proving that something extraordinary happened. Of course, not every gamma-ray burst fits this profile. Many are tied to supernova or neutron star collisions, but a handful of these events defy conventional explanations. Their energy signatures don't match known astrophysical processes, and their afterglows behave in ways that make physicists scratch their heads. These outliers could be prime candidates for white hole sightings, cosmic SOS signals from another reality. The implications are staggering. If white holes are real, they wouldn't just be exotic oddities. They'd be proof that our universe is part of a vast, interconnected network where matter and energy flow between realities like water through hidden underground rivers. Every unexplained cosmic explosion could be a message in a bottle from another dimension, hinting at universes where physics plays by different rules. And if we ever learn to read those messages, we might discover that the boundaries of existence are far more porous than we ever dared to dream. Quantum entanglement already bends our minds at the microscopic scale, particles linked across vast distances, instantly mirroring each other's states no matter how far apart they are. But what if this spooky connection isn't limited to tiny particles? What if entire universes are entangled, their fates intertwined in a cosmic dance that defies the very fabric of spacetime? This idea takes quantum weirdness to its ultimate extreme, proposing that the same invisible threads binding electrons might also stitch together separate realities in the multiverse. Imagine two universes born from the same quantum fluctuation, their initial conditions perfectly mirrored. Like twins separated at birth, they'd retain a mysterious connection, their histories unfolding in tandem even as they drift apart in the vastness of higher dimensional space. A star exploding in one universe could trigger an identical supernova in the other, not through any physical signal traveling between them, but through a deeper, instantaneous correlation woven into their very foundations. It's as if the multiverse has its own hidden wiring, a network of quantum shortcuts bypassing the normal rules of cause and effect. The implications would rewrite our understanding of reality. If universes can influence each other faster than light, it challenges Einstein's bedrock principle that nothing can outpace light speed. But in the quantum realm, entanglement already defies this. Particles communicate instantaneously, as if space and time don't apply to them. Scale this up, and the cosmic microwave background in our universe might bear faint fingerprints from events in another, like shadows cast through a veil. Some researchers speculate this could explain certain anomalies in the CMB, unusual patterns that seem too precise to be random, as if something on the other side is tugging at the fabric of our reality. How could we ever detect such a connection? One clue might lie in synchronized fluctuations between distant regions of space. If 2 points in our universe suddenly exhibit identical quantum behavior with no apparent cause, it could signal an unseen link to another reality. Another tantalizing possibility involves black holes. If information isn't truly lost in a black hole, as quantum theory insists, but instead transmitted somewhere else, entangled universes might be the answer. The data swallowed by a black hole in one universe could reappear as Hawking radiation in its entangled partner, like a message passed through a cosmic trapdoor. Skeptics argue this stretches quantum mechanics beyond recognition, and they're not wrong. But consider this: if entanglement can bind particles across galaxies, why not universes across the multiverse? The math doesn't forbid it, it merely asks us to rethink what's possible. After all, the history of physics is a story of boundaries being shattered, from the Earth-centered cosmos to the quantum revolution. Each time we've assumed we understood the limits of reality, the universe has proven stranger. Perhaps the most profound takeaway isn't whether entangled universes exist, but what their possibility reveals about nature's deepest layers. If causality can leap between realities, then time and space might be illusions, surface features of a far richer tapestry. We might live in a multiverse where every event, every particle, every breath is part of an unfathomably vast web, one where nothing truly happens in isolation. Roger Penrose's cyclic conformal cosmology, or CCC, reimagines the universe's life cycle in a way that's as elegant as it is radical. Instead of a one-time Big Bang followed by endless expansion or a slow heat death, Penrose proposes something far more poetic, an endless cycle of universes, each one reborn from the ashes of the last through a process called conformal rescaling. Picture the cosmos not as a linear story with a beginning and end, but as an infinite series of chapters, each one starting where the previous one left off yet utterly transformed. At the heart of CCC lies a daring mathematical trick. As a universe expands toward its heat death, all matter eventually decays into radiation, and black holes evaporate into nothingness. What remains is a cold, empty expanse where time and distance lose all meaning. Penrose suggests that at this point, the universe can be mathematically rescaled, stretched and smoothed until its infinite, featureless end becomes indistinguishable from a new Big Bang. It's like taking a faded, crumpled map and redrawing it with fresh ink, turning the tattered edges of one journey into the blank canvas of the next. But here's where it gets truly fascinating. Penrose believes traces of the previous universe might linger in the next one, etched into the fabric of reality itself. These cosmic fingerprints, dubbed Hawking points, are hypothesized to be faint, circular imprints in the cosmic microwave background, the afterglow of the Big Bang. Named after Stephen Hawking, they're thought to be the last whispers of supermassive black holes from the prior universe, their evaporation leaving behind subtle hotspots in the radiation bath of the new cosmos. Imagine finding the shadow of a long dead star in the sky, a ghostly reminder that this isn't the first universe, and it won't be the last. Supporters of CCC point to anomalies in the SIMB, unexplained concentric rings of temperature variation that don't fit standard cosmological models. These rings, some argue, could be the smoking gun of a pre-Big Bang universe, its black hole collisions reverberating across the reset like echoes in a canyon. Skeptics counter that these patterns might just be statistical noise, but the idea is tantalizing. If true, we might be living in a universe with ancestral memories, its earliest light encoded with secrets from a time before time. The implications are profound. If CCC is correct, the laws of physics might not be arbitrary constants but evolved traits, subtly reshaped with each cosmic rebirth. Black holes, rather than being cosmic dead ends, could be the universe's way of preserving information across cycles, their Hawking radiation acting as a bridge between epochs. Even the arrow of time, the one-way flow from past to future, might be part of this grand reset, flipping direction with each new cycle like an hourglass turned upside down. Could we ever prove such a wild idea? Future telescopes mapping the CMB in unprecedented detail might uncover more of these mysterious circles, while advances in quantum gravity could reveal whether information truly survives the transition between universes. Until then, CCC remains one of the most breathtaking visions of reality ever conceived, a cosmos without end, where every death is a prelude to rebirth, and the universe itself is both the question and the answer. Dark energy, the mysterious force driving the universe's accelerating expansion, has long been one of cosmology's greatest puzzles. We know it makes up about 68% of the universe's energy density, pushing galaxies apart faster and faster, but its true nature remains elusive. The simplest explanation, a cosmological constant embedded in spacetime itself, raises more questions than answers. Why is its value so staggeringly small compared to theoretical predictions off by a factor of 1 followed by 120 zeros? This discrepancy, known as the cosmological constant problem, hints that we might be missing something fundamental. What if dark energy isn't an intrinsic property of our universe at all, but the fingerprint of other realities pressing against ours? Imagine the multiverse as a vast foam of bubble universes, each expanding or contracting in its own rhythm. If these bubbles occasionally press against each other, the force exerted by neighboring universes could manifest in ours as dark energy, a cosmic pressure warping spacetime from the outside. Think of it like two balloons pressed together. Where they meet, the rubber stretches and deforms. Similarly, the gravitational pull or push from an adjacent universe might be subtly warping our cosmos, creating the illusion of an internal force we can't directly detect. This idea gains traction when you consider the timing of dark energy's dominance. For billions of years, gravity ruled cosmic expansion, slowing it down as matter clumped into galaxies. Then, around 5 billion years ago, something flipped. Dark energy took over, and the universe began accelerating. Could this inflection point mark the moment a neighboring universe drifted close enough to exert noticeable pressure? Simulations of colliding bubble universes show similar behavior, a gradual buildup of repulsive force as the boundaries interact, mimicking the observed acceleration without fine-tuning a cosmological constant. The cosmological constant problem might also find an elegant solution in this framework. Instead of asking why dark energy's value is so peculiarly small, we'd be asking why the pressure from adjacent universes happens to balance out the way it does. In an infinite multiverse, there's bound to be a slice where external forces align to produce the delicate conditions we observe. It's like standing in a crowd where everyone's jostling by chance. You might find a pocket where the pushes and pulls cancel out just enough to feel stillness. Even the universe's large-scale structure could hold clues. If dark energy is an external force, its effects might not be perfectly uniform. Subtle anisotropies, direction-dependent variations in the expansion rate, could reveal where neighboring universes are closest. Some researchers are already scouring galaxy surveys and the cosmic microwave background for these telltale asymmetries, hunting for patterns that don't fit the standard dark energy narrative. Of course, skeptics argue this is speculative, and they're right, but that's the beauty of cosmology's biggest mysteries. Whether dark energy springs from within or without, its strangeness forces us to rethink the boundaries of reality. If future observations ever reveal evidence of multiversal pressure, it would mean our universe isn't just expanding, it's breathing in sync with unseen neighbors, part of a grand cosmic ballet we're only beginning to hear the music for. Wormholes have long been the stuff of science fiction, mysterious tunnels through spacetime that could, in theory, connect distant points in the universe or even bridge separate realities. But what if these cosmic shortcuts aren't just speculative fantasies? Einstein's equations of general relativity actually predict their existence. Known as Einstein-Rosen bridges, these structures emerge as solutions to the math describing how spacetime bends under extreme gravity. Picture a piece of paper folded so two distant dots touch. A wormhole would be like poking a pencil through the page, creating an instant tunnel between them. Now imagine that tunnel doesn't just span our universe but punches through to another, linking one reality to another like a hidden backdoor in the cosmos. The catch: natural wormholes, as predicted by relativity, would be catastrophically unstable. The moment anything tried to pass through even a single photon, the tunnel would snap shut like a rubber band pulled too tight, crushing whatever ventured inside. But here's where things get interesting. Modern physics suggests there might be a way to prop these tunnels open using something called exotic matter. Unlike normal matter, which gravitates inward, exotic matter would have negative energy density, exerting a sort of anti-gravity that could counteract a wormhole's collapse. It's like trying to keep a doorway open by propping it with a spring that pushes outward instead of a weight that pulls it shut. The implications for multiverse travel are staggering. If stable wormholes exist, they could form an intricate web of pathways threading through higher dimensions, connecting universes with different physical laws or timelines. Some theories propose that quantum fluctuations in the early universe might have seeded microscopic wormholes, which then stretched and grew alongside expanding space-time. Over billions of years, these tiny tunnels could have woven themselves into a vast network, a cosmic subway system where each stop is another reality. But how would we ever find one? One tantalizing clue might lie in the behavior of black holes. If a wormhole connects 2 points in space or 2 universes, matter falling into one end could theoretically emerge from the other. Astronomers have already spotted bizarre instances where black holes seem to eject material with unexplained energy. Could these be glimpses of matter resurfacing through a distant wormhole mouth? Others suggest looking for gravitational lensing anomalies. If a wormhole bends light in a specific way, it could create strange double images or rings in the sky where none should exist. Of course, the challenges are immense. Exotic matter remains purely hypothetical, and the energy required to stabilize a macroscopic wormhole might be beyond anything we could harness. Yet the math doesn't forbid it, and in a multiverse where infinite possibilities play out, somewhere, some civilization might have cracked the code. If they did, the universe next door could be just a step away. Until then, these ghostly tunnels remind us that the fabric of reality might be far more malleable and far more connected than we ever dared to dream. One of the most unsettling ideas in quantum mechanics isn't just about particles behaving strangely. It suggests that your very consciousness could be steering your path through the multiverse. The quantum suicide thought experiment takes Schrödinger's famous cat to a chilling extreme, replacing the feline with a human observer and the poison vial with a trigger-happy quantum device. Here's how it works. Imagine a gun wired to a quantum particle in superposition. A 50-50 chance of firing each time you pull the trigger. In one universe, the gun goes off. In another, it doesn't. Now suppose you're the one holding it. From your perspective, no matter how many times you pull that trigger, you'll only ever experience the outcome where the gun jams. You'd keep jumping to the timeline where you survive, effectively becoming immortal in your own subjective reality. This isn't just a grim party trick. It forces us to confront deep questions about consciousness and probability. If the many worlds interpretation is correct, every quantum event spawns branching realities, but your awareness only follows the path where you continue to exist. It's like rolling a die with a million sides marked death and one marked alive. Statistically, you'll always land on the one that lets you keep playing. Critics argue this reduces consciousness to a cosmic lottery where sentient beings inevitably find themselves in ever more improbable timelines, like characters in a video game who respawn every time they lose. But what does this imply about death itself? If every choice creates new forks in the road, does consciousness naturally gravitate toward the paths where it persists? Some interpretations suggest that subjective immortality might not be reserved for extreme scenarios like quantum suicide. It could apply to everyday risks. Every time you cross the street, take a flight, or even eat questionable sushi, there's always a version of you that makes it through unscathed. In this view, death might be less of an endpoint and more of a branching point where your awareness simply stops following certain paths. The philosophical ripple effects are staggering. If consciousness is tied to survival, does that mean the universe has a built-in bias toward observers who endure against all odds? This idea, sometimes called the anthropic principle on steroids, could explain why we find ourselves in a universe seemingly fine-tuned for life, because only in such a reality could we exist to notice it. Even more unsettling, if this holds true, there could be countless ghost versions of you who didn't make it, their experiences snuffed out like candle flames in a draft. Of course, skeptics dismiss this as solipsistic nonsense. After all, people die every day, and we don't see evidence of consciousness hopping timelines. But quantum mechanics has a history of defying intuition. The double-slit experiment once seemed ludicrous too. Until we fully understand how consciousness intertwines with quantum reality, the question remains open. Are we all unwitting participants in a game of multiversal Russian roulette with our awareness forever dodging the bullet? Picture zooming into the fabric of reality, deeper and deeper, only to discover that every layer reveals another cosmos just as vast and complex as the one you left behind. This is the heart of the fractal multiverse, a vision of existence where universes nest inside one another like an infinite set of cosmic Russian dolls, each one a perfect replica in structure but scaled infinitely larger or smaller than the last. It's a universe within atoms, galaxies within particles, an endless recursion where the patterns of creation repeat at every level. At first glance, this might sound like pure fantasy, but the math behind fractals infinitely repeating geometric patterns shows up everywhere in nature. From the branching of trees to the jagged edges of coastlines, even the intricate folds of our own brains, self-similarity seems baked into the universe's design. So why not apply that principle to the cosmos itself? If reality is fractal, the same physical laws governing galaxies might also dictate the behavior of subatomic particles, just operating at different scales. Imagine a hydrogen atom not as a tiny, isolated system, but as a micro-universe, its electron orbits mirroring the spiral arms of galaxies in a cosmos too small for us to see. This idea could solve one of physics' biggest mysteries, fine-tuning. Why do the fundamental constants, the strength of gravity, the mass of an electron, seem so perfectly calibrated to allow stars, planets, and life to exist? In a fractal multiverse, there's no need for a cosmic architect. Instead, the fine-tuning might emerge naturally from recursive symmetry. If every universe inherits its laws from the one above it, like a code passed down through generations, slight variations would cancel out over infinite layers, leaving only the most stable, life-permitting configurations. It's like shaking a box of sand. Eventually, the grains settle into the most stable arrangement, no fine-tuning required. Some theorists take this further, suggesting black holes might be the gateways between these nested realities. When a black hole collapses into a singularity, perhaps it doesn't crush matter into oblivion but compresses it into the seed of a new universe, one that blossoms inside its own spacetime, unseen by the parent cosmos. The equations of general relativity don't forbid this, they simply describe a boundary, the event horizon beyond which we can't see. What if that boundary isn't an end but a beginning? The implications are dizzying. If universes truly nest inside one another, the Big Bang might not have been the absolute beginning but a transition point, a rebirth from a prior universe's collapse. Ancient light in the cosmic microwave background could carry echoes of that ancestor cosmos, subtle fingerprints in the radiation. Even dark matter might find an explanation. Particles from a parent universe leaking into ours, their gravity felt but their origins forever hidden. Could we ever detect evidence of this fractal reality? Some researchers propose looking for anomalies in quantum behavior patterns repeating at scales where they shouldn't, like echoes of deeper cosmic layers. Others suggest searching for geometric symmetries in the distribution of galaxies, hunting for large-scale structures that mirror atomic geometries. It's a long shot, but if proven, it would redefine our place in existence not just as inhabitants of a universe, but as threads in an infinite tapestry, woven across dimensions we're only beginning to glimpse. Perhaps the most humbling thought is this: if the fractal multiverse is real, then our entire cosmos might be nothing more than a speck inside some unimaginably vast superstructure, itself just one link in an endless chain. And somewhere, on a scale too colossal to comprehend, another version of you might be pondering the same idea, staring into the abyss of their own fractal sky. The universe tends toward chaos. That's the relentless march of entropy, the slow unraveling of order into disorder. But what if, against all odds, randomness conspired to create not just order but consciousness itself? Enter the mind-bending concept of Boltzmann branes, hypothetical self-aware entities that could spontaneously form from quantum fluctuations in an otherwise empty void. Named after physicist Ludwig Boltzmann, who first grappled with the statistical nature of entropy, these disembodied observers aren't just theoretical curiosities. They might hold the key to one of the strangest multiverse theories yet: the idea that some memories of cross-universe travel could be illusions, hallucinations baked into the fabric of reality by sheer cosmic accident. Picture a universe that's endured for trillions upon trillions of years, its stars long dead, its energy all but spent. In this cold, featureless expanse, the improbable becomes inevitable. Given enough time, random particle interactions could by pure chance arrange themselves into a fully formed brain, complete with fabricated memories of a life it never lived. This Boltzmann brain might wake up convinced it's a human who just stepped through a portal from another reality, its entire past an elaborate fiction conjured by entropy's dice roll. Now scale that up to the multiverse. In an infinite sea of universes, some might be dominated by these phantom observers, their false histories indistinguishable from actual lived experience. The implications are unsettling. If Boltzmann branes are possible, how do we know we're not one of them? Every memory of your childhood, every sensation of the present moment, could be a fleeting fluctuation in the quantum foam, destined to dissolve as quickly as it formed. Some versions of this theory suggest that the overwhelming majority of conscious experiences in the cosmos belong to these transient entities, making real observers like us statistically insignificant outliers. It's like discovering that every grain of sand on a beach is secretly a tiny supercomputer running simulations. The weight of probability crushes our intuition. But here's where multiverse interactions add a twist. If a Boltzmann brane forms with false memories of crossing from another universe, could those memories contain real information? Imagine one of these apparitions recalling precise details about a parallel reality details that later turn out to match independent discoveries in physics. Would that be coincidence or evidence that some fluctuations tap into deeper cosmic truths? The boundaries between simulation, hallucination, and reality start to blur. Critics argue this is philosophy masquerading as physics, and they're not wrong. The Boltzmann brane thought experiment was originally meant to highlight problems with certain cosmological models, not propose a serious theory of consciousness. Yet in a multiverse where anything that can happen does happen, it forces us to confront the fragility of our own perceptions. After all, if nature can conjure a fully formed mind from chaos, what else might be possible? The answer might lie in the very fabric of existence, where the line between real and imagined isn't just thin, but constantly rewriting itself. What if black holes aren't just cosmic graveyards, but cosmic nurseries birthing new universes with slightly tweaked physics, each one competing for survival in a vast multiversal ecosystem? This is the spine of Lee Smolin's daring theory of cosmological natural selection, where universes don't just exist, they evolve. Picture the multiverse as a sprawling forest, with each universe a unique tree. Some thrive and spread their seeds, others wither. But here, the seeds are black holes, and the forest floor is littered with failed experiments in physics. At the heart of this idea is a radical twist on Darwinism. Just as biological traits are passed down and refined through generations, Smolin suggests the laws of physics might be shaped by a similar process. When a black hole forms, its crushing singularity could trigger the birth of a new universe inside it, a cosmic offspring inheriting its parents' physical constants but with tiny random variations. Most of these baby universes would be stillborn, their laws too unstable to sustain complexity. But occasionally, one emerges with just the right tweaks to outperform its ancestors. And what makes a universe fit? The ability to produce more black holes. Universes that optimize gravity, star formation, or entropy to spawn plentiful black holes would dominate the multiverse landscape, while those that don't fade into obscurity. This elegantly explains one of physics' biggest mysteries: why our universe seems so finely tuned for life. It's not that life-friendly constants are special, it's that they're a byproduct of selection pressure. Stars that collapse into black holes require precise balances of nuclear forces and gravity. Too weak and stars fizzle out, too strong and they burn up before collapsing. A universe that gets this sweet spot right becomes a black hole factory, flooding the multiverse with its offspring. In this light, we don't live in a designed universe, we live in a winning one, its laws honed by eons of cosmic trial and error. Critics pounce on a glaring question: where's the evidence? Smolin proposes a testable prediction. If his theory holds, the laws of physics should be optimized specifically for black hole production, not for life. That means certain constants, like the neutron's mass or the cosmological constant, would sit at values that maximize black holes, even if tweaking them slightly might make life more likely. Intriguingly, some calculations suggest our universe's parameters do align with this black hole optimum, though the debate rages on. The implications ripple far beyond cosmology. If true, multiverse Darwinism would mean black holes are the universe's reproductive organs, and space-time itself is a kind of genetic code. Colliding galaxies, dying stars, even the expansion rate of the cosmos, all could be part of an unseen evolutionary arms race. It's a humbling thought. The forces that govern galaxies might exist not by necessity, but simply because they worked in the ruthless arena of cosmic selection. And if that's the case, the next time you gaze at the night sky, you're not just looking at stars, you're looking at the descendants of a multiversal dynasty, sculpted by time and chance into engines of creation. Consciousness might be more than just a byproduct of the brain. It could be a fundamental feature of reality, woven into the fabric of the cosmos like gravity or electromagnetism. This is the heart of panpsychism, the idea that mind isn't confined to living beings but is a basic property of matter itself, from quarks to galaxies. If true, it raises a staggering possibility. What if consciousness isn't just observing the universe but actively shaping it, or even bridging gaps between realities? Quantum mechanics already blurs the line between observer and observed. In the famous double-slit experiment, particles behave as waves until measured, at which point they choose a definite state. This observer effect suggests that consciousness, the act of measurement, somehow influences reality. Proponents of panpsychism take this further, proposing that all matter has a rudimentary form of awareness, and that complex minds like ours emerge from this universal substrate. If consciousness is intrinsic to existence, maybe it doesn't just perceive the multiverse, it navigates it. Imagine your mind as a radio receiver, tuning into different frequencies of reality. Every decision, every moment of focus could subtly shift which universe you're locked onto within the vast multiversal spectrum. This isn't just philosophical speculation. Some interpretations of quantum mechanics suggest that wave function collapse the moment probabilities resolve into definite outcomes might involve a kind of selection process where conscious observers choose their path through the branching multiverse. It's as if reality is a cosmic choose-your-own-adventure book, and consciousness is the finger tracing the words. Near-death experiences and psychedelic states add fuel to this fire. People who have brushed against death often report vivid encounters with alternate versions of themselves or timelines that feel equally real. Similarly, substances like DMT seem to dissolve the boundaries of individual awareness, plunging users into realms that defy conventional physics. Could these phenomena be glimpses of consciousness temporarily slipping its local constraints and interfacing with other layers of the multiverse? The implications are profound. If consciousness connects universes, then meditation, intention, or even focused thought might not just be inner experiences, they could be tools for navigating the multiverse. Some theories suggest that synchronized group consciousness, like global meditation events, could create resonant ripples in reality, nudging the collective timeline toward certain outcomes. It's a modern twist on ancient ideas that the mind isn't just in the world is in the mind. Skeptics, of course, dismiss this as metaphysics masquerading as physics. Yet the hard problem of consciousness, why and how subjective experience arises from matter, remains unsolved. If panpsychism offers even a partial answer, it forces us to reconsider everything from quantum experiments to the nature of death. After all, if consciousness is a cosmic constant, what happens to it when the body ceases? Does it dissipate like smoke, or does it simply retune to another frequency in the multiversal symphony? Whether proven or not, this theory invites us to see our minds not as passive spectators, but as active participants in a reality far stranger and more interconnected than we ever imagined. The next time you make a choice or even observe a sunset, ask yourself, are you just witnessing the universe, or are you, in some small way, helping to create it? In 2011, a team at CERN made headlines with a finding that seemed to defy the laws of physics: neutrinos appearing to travel faster than light. The results were later attributed to a faulty fiber optic connection, but what if the glitch wasn't just equipment failure? What if it was a fleeting glimpse of a phantom universe brushing against ours, a reality where the speed limit isn't light but something slightly different? This is the spine of the phantom universe theory, the idea that universes with marginally altered physical constants might momentarily ghost into our own, leaving behind traces that vanish as quickly as they appear. Think of reality as a vast orchestra, with each universe playing its own distinct melody governed by its unique constants. Most of the time, these cosmic symphonies stay separate. But if two universes vibrate at frequencies just close enough, their harmonies might briefly overlap, creating dissonant notes in the fabric of existence. In that transient overlap, particles from a universe with a slightly higher speed of light could slip into ours, appearing to break our rules before fading back into the multiversal background. It's like tuning a radio and catching a few seconds of a station that shouldn't exist, a signal from somewhere else. The implications stretch far beyond one anomalous experiment. Phantom universes could explain other cosmic oddities, particles that seem to vanish in detectors, energy fluctuations with no discernible source, or even the infamous wow signal, a mysterious radio burst from space that's never been repeated. These might not be mere glitches, but echoes of neighboring realities flickering in and out of alignment with ours. The key lies in the subtlety of the differences. A universe where gravity is 1% stronger or electromagnetism a fraction weaker wouldn't manifest as a fully formed alternate Earth, but as fleeting distortions at the quantum level, like shadows cast by a candle flickering in another room. Some physicists speculate that these interactions could be more than random noise. If we could map the anomalies, they might reveal patterns, clusters of impossible events that hint at the underlying structure of the multiverse. Imagine detecting a series of faster-than-light neutrinos, not in random directions, but all aligned along a specific vector in space. That could suggest a phantom universe drifting past ours in a way that leaves a directional fingerprint, like a comet's tail of borrowed physics. Skeptics argue this is a cosmic Hail Mary, an excuse for every unexplained blip in the data. But consider how often science has rewritten the rules based on what once seemed like noise. The cosmic microwave background, now a cornerstone of cosmology, was initially dismissed as pigeon interference in a radio antenna. The line between artifact and discovery is often thinner than we think. Whether phantom universes are real or not, the theory forces us to confront a humbling possibility: that the laws we consider absolute might just be local ordinances, rubber-stamped by our corner of the multiverse. And if that's true, the next time an experiment defies expectations, it might not be a mistake. It could be a message from a reality where the rules are written differently, and the impossible is just another Tuesday. The ekpyrotic universe theory turns the Big Bang narrative inside out, suggesting our cosmos wasn't born from a singularity, but from a cataclysmic collision between two higher dimensional membranes drifting through an unseen void. Picture two sheets of paper floating in a breeze, slowly drawn together until they slam into each other with enough force to ignite an entire reality. This isn't just poetic imagery, it's a radical alternative to cosmic inflation, proposing that the heat and density we attribute to the Big Bang were actually the aftermath of a multiversal fender bender. What makes this model so compelling is how it reimagines time itself. Instead of a definitive beginning, the ekpyrotic scenario paints existence as part of an endless cycle, universes expanding, cooling, and eventually drawn back into collisions that reset the cosmic clock. Each crash transfers energy from the higher dimensional bulk into our familiar three-dimensional space, jump-starting a new epoch of expansion. Think of it like a cosmic game of pinball, where branes ricochet through extra dimensions, each impact birthing a fresh universe with its own unique physics. But how often do these universe-spawning collisions occur? The math suggests it depends on how these branes move through the higher dimensional landscape. Some models propose they oscillate like pendulums, destined to collide at regular intervals over mind-boggling timescales. Others imagine a more chaotic multiverse, where branes drift unpredictably, their collisions as random as bumper cars in a darkened arena. If the latter is true, new universes might be born in sporadic bursts, cosmic lightning strikes with no set rhythm. The implications are staggering. If ekpyrosis is real, the constants of nature, the strength of gravity, the mass of electrons, might not be arbitrary but sculpted by the specific angle and energy of each collision. One smash might produce a universe where stars burn forever. Another might spawn a reality too unstable for atoms to form. This could explain why our universe seems so finely tuned. We're simply the product of a brane crash that struck the right balance for complexity to emerge. Could we find evidence of our universe's violent birth? Proponents scour the cosmic microwave background for telltale patterns, elongated temperature fluctuations, or nested concentric rings that might betray the direction of the ancient impact. Others hunt for primordial gravitational waves, subtle ripples in spacetime that could carry echoes of the collision's shock waves. So far, the smoking gun remains elusive, but the search reshapes how we see existence. If confirmed, it would mean we're not just stardust, but the fallout of a higher dimensional wreck, drifting in the aftermath of forces we've yet to fully comprehend. Quantum teleportation already bends the rules of reality here in our universe, transmitting the quantum state of a particle across vast distances instantly, as if information itself has learned to outpace light. But what if this eerie phenomenon isn't limited to our cosmic neighborhood? Some theorists propose that with the right conditions, quantum teleportation could scale up far beyond labs and satellites, acting as a bridge between entire universes. The secret lies in something called multiverse qubits, hypothetical particles entangled not just across space, but across the boundaries of reality itself. Picture this, a pair of particles so deeply linked that measuring one in our universe instantly determines the state of its partner in another. Unlike ordinary entanglement, where particles share a connection within the same cosmos, multiverse qubits would ignore the divide between realities entirely. It's as if two radios were tuned to the same frequency, but one was broadcasting from a parallel dimension. The implications are staggering. If such a link existed, we could, in theory, encode information into a particle here and decode it light years away in another universe, bypassing the need for wormholes or warp drives. The mechanics might rely on cosmic-scale entanglement, where entire regions of spacetime share quantum correlations. Imagine two universes born from the same quantum fluctuation, their initial conditions perfectly mirrored. Like twins separated at birth, they'd retain a hidden connection, allowing signals to pass between them instantaneously. This wouldn't violate relativity's cosmic speed limit, since no physical object is traversing the gap, but it would rewrite the rulebook on communication. A civilization in Universe A could send data to Universe B without any direct travel, like passing a note through a wall that doesn't exist for anyone else. Of course, the hurdles are immense. Conventional quantum teleportation requires precise control and error correction to prevent decoherence, the breakdown of fragile quantum states. Scaling this up to universes would demand technology far beyond our grasp, not to mention proof that multiverse qubits are even possible. Some models suggest these exotic particles could emerge naturally in the chaotic aftermath of black hole collisions or during cosmic inflation, forming threads between realities like quantum spider silk. Others argue we'd need to engineer them deliberately, weaving entanglement into the fabric of spacetime itself, yet the potential payoff is irresistible. If multiverse quantum teleportation works, it would offer a backchannel to realities with entirely different physical laws. Imagine receiving data from a universe where gravity operates inversely or time flows backward, not as science fiction, but as quantum code deciphered from an alien physics. Even wilder, if consciousness has quantum underpinnings, as some theories propose, could teleportation protocols one day allow minds to traverse the multiverse, projecting awareness across realities like a signal hopping between frequencies? For now, this remains the stuff of equations and thought experiments, but every breakthrough in quantum computing brings us closer to manipulating entanglement in unprecedented ways. Perhaps one day a lab somewhere or somewhen will detect an anomaly in their teleportation data, an inexplicable signature that whispers, "Message received from the other side." Until then, the idea alone stretches our imagination, proving once again that the universe's strangest phenomena might not be limits but invitations to look beyond. We think of dark matter as an invisible scaffold holding galaxies together. But what if it's something far stranger, an entire shadow universe, complete with its own stars, planets, and maybe even life, invisibly layered over our own? Picture a cosmic echo where every atom in our world has a dark matter counterpart, each particle dancing just out of phase with reality as we know it. These shadow universes wouldn't just be faint reflections. They'd be fully realized realms, built from particles that barely interact with ours except through gravity's faintest whisper. A civilization could thrive there, its cities pulsing with dark energy, its people utterly unaware of our existence, while we, in turn, pass through their world like ghosts. The math behind this idea isn't science fiction. Certain extensions of particle physics, like the mirror matter hypothesis, propose that every known particle has a hidden twin, a dark electron, a dark proton governed by similar but distinct forces. These shadow particles would form their own periodic table, their own chemistry, even their own versions of DNA. Stars in such a universe might burn dark photons instead of light, warming planets where life evolved under skies our telescopes could never pierce. The eerie part, if these shadow beings developed technology, their buildings and machines would occupy the same space as ours, intangible to our touch. You could walk through one of their structures every day and never know. Gravity might be the only bridge between our worlds. Dark matter's gravitational pull shapes the galaxies we see, but what if those subtle tugs are more than just passive mass? Some researchers speculate that anomalies in galactic rotation, places where gravity seems to warp in unexpected ways, could be evidence of dense shadow objects, dark stars, even dark black holes bending spacetime from dimensions we can't perceive. There's even a chilling possibility that shadow civilizations might have detected us first, puzzling over the unexplained gravitational distortions caused by our sun and planets in their cosmos. The most haunting question isn't whether shadow universes exist, but whether interaction is possible, or worse, inevitable. If dark matter particles occasionally leak into our reality through rare quantum interactions, could shadow organisms do the same? There are fringe theories that certain high-energy cosmic rays, which strike Earth's atmosphere with no known source, might be shrapnel from shadow supernova. Even more unsettling, if dark life evolved to harness these leaks, it might perceive our universe as a resource. Imagine a shadow scientist right now, probing the boundary between realities, unaware that their experiments are creating eerie fluctuations in our particle accelerators. Yet for all the tantalizing possibilities, shadow universes remain just beyond our grasp. Without a way to directly observe or communicate with dark matter, we're left with circumstantial evidence: the gravitational fingerprints, the unexplained cosmic signals, the nagging sense that the universe feels designed to keep us separate. But if we ever crack the code, the revelation would rewrite not just physics but philosophy. We'd have to accept that reality has been a shared space all along, that every empty corner of the cosmos might be teeming with unseen neighbors, their lives unfolding in parallel to ours, forever close and forever out of reach. Some moments in life feel eerily familiar, like you've lived them before. A conversation where you know the next words before they're spoken, a street corner that pulls at your memory though you've never been there. Most dismiss this as déjà vu, a trick of the brain. But what if these flashes aren't just neurological hiccups? What if they're echoes bleeding through from another timeline, ripples in the multiverse's time stream caused by seismic events in parallel realities? Picture a stone tossed into a pond. The impact sends waves radiating outward, distorting the water's surface far from the original splash. Now imagine that pond is the fabric of existence, and the stone is a cataclysmic event. A world war, a scientific breakthrough, even the birth or death of a single pivotal individual in another universe. The shockwaves of that event might propagate through higher dimensions, subtly warping the timelines of neighboring realities. These distortions could manifest as fleeting sensory glitches, dreams that feel like memories, gut instincts about events yet to unfold, or that spine-tingling certainty that you've stood in this exact moment before. This idea gains traction when you examine how time operates in quantum physics. At the subatomic level, particles don't strictly obey linear cause and effect. Experiments have shown that observing a particle in the present can retroactively alter its past state, a phenomenon called retrocausality. If particles can blur the arrow of time, why not entire universes? Major events in one reality might cast shadows backward and forward across the multiverse, imprinting fragments of information on other timelines like cosmic crosstalk. History's most vivid cases of precognition fit this pattern. Take the haunting accounts of people who dreamed of the Titanic sinking weeks before it happened, or the civilians who cancelled travel plans on September 10, 2001, citing unexplainable dread. While skeptics attribute these to coincidence or selective memory, the time stream ripple theory offers an alternative. These individuals might have briefly tuned into a reality where the tragedies had already occurred, their subconsciousness catching whispers from a parallel timeline's aftermath. Even more intriguing are shared déjà vu experiences, entire groups recalling an event that never happened. In 2016, thousands worldwide swore they remembered Nelson Mandela dying in prison during the 1980s despite his passing decades later. This Mandela effect could be more than faulty memory. If multiple minds access the same ripple from an adjacent timeline, it suggests these distortions aren't random but cluster around pivotal historical nodes where universes diverge. The mechanics behind these ripples might resemble gravitational waves, but instead of space-time, they'd vibrate through the quantum fields that underpin reality. In string theory, every event creates vibrations in higher dimensional, Brane's multiversal membranes that could transmit energy across realities. A supernova explosion in one universe might send tremors through the brain, inducing faint premonitions of stellar death in observers light years away in another. Could we ever distinguish these ripples from imagination? Emerging tech like quantum EEG might hold clues. If déjà vu correlates with detectable fluctuations in brain particles entangled across timelines, we could pinpoint moments when the brain receives anomalous data. Alternatively, global surveys tracking precognitive dreams against major world events might reveal statistical anomalies, clusters of foresight preceding disasters in ways chance can't explain. Skeptics rightly demand rigor, but history shows even outlandish ideas can gain footing. Before continental drift was accepted, the notion that Africa and South America once touched seemed absurd. Now we map their ancient collisions in schoolbooks. Similarly, time stream ripples might transition from fringe speculation to testable science, especially if advanced simulations can model how multiversal events propagate. Perhaps the most poetic implication is that no universe truly exists in isolation. Your déjà vu on a Tuesday morning might be the aftershock of a revolution on another Earth. A child's vivid dream of a burning city could be the distant cry of a world where history took a darker turn. In this view, the multiverse isn't just a collection of alternate realities. It's a living, resonant network where every event, no matter how small, sends whispers across the threads of time. What if the universe isn't just governed by mathematics? What if it is mathematics? Max Tegmark's mathematical universe hypothesis takes the multiverse concept to its most extreme and elegant conclusion. Every structure that can exist mathematically does exist physically. No equations left behind. This isn't just about parallel worlds with tweaked physical constants. It's about realities built from entirely different mathematical frameworks, some so alien they defy visualization. Think of it as the ultimate cosmic library, where every conceivable equation, from the simple elegance of Euclidean geometry to the fractal madness of infinite dimensional manifolds, gets its own universe. At the heart of this idea is a radical redefinition of reality. Most theories treat physics as the foundation, with math as the language we use to describe it. Tegmark flips this. Mathematics is the foundation, and what we call physics is just our subjective experience of one particular mathematical structure, the one that generates stars, atoms, and conscious observers like us. In this level Roman 4 multiverse, universes aren't branches or bubbles but standalone mathematical objects, each self-contained yet part of an infinite ensemble. A universe where time has 5 dimensions exists. One where gravity repels and entropy runs backward also exists. The only rule is logical consistency. If it can be described without contradiction, it's out there somewhere. But here's the twist that makes this more than abstract philosophy: interactions. If all mathematical structures exist, some might share overlapping symmetries or isomorphic patterns, like 2 different equations producing the same graph. These shared structures could act as bridges between universes, allowing information or even matter to tunnel from one mathematical realm to another. Picture a universe based on hyperbolic geometry briefly aligning with ours at a quantum level, its strange angles imprinting as fleeting anomalies in particle collisions. Or consider a reality built on prime number sequences communicating through number theory's universal language, leaving cryptographic signatures in the cosmic microwave background. The implications are dizzying. If Tegmark's right, then every breakthrough in pure mathematics isn't just uncovering abstract truth, it's mapping undiscovered universes. Proving the Riemann hypothesis might reveal a cosmos where prime numbers physically manifest as crystalline structures. Solving Navier-Stokes equations could unlock a fluidic universe with no solid matter. Even more mind-bending, consciousness itself might be a mathematical pattern, meaning you could exist in countless forms across the multiverse, as a neural network in one reality, a quantum field vibration in another, or an entirely non-physical theorem in a universe made of pure logic. Skeptics argue this blurs the line between reality and imagination, and they're not wrong, but Tegmark counters that the same criticism once applied to parallel universes or curved spacetime, now cornerstones of modern physics. The real test: predictions. If mathematical universes interact, their overlaps might leave fingerprint statistical anomalies in particle behavior, or mathematical constants appearing with unnatural frequency in nature. Some researchers already scour pi's infinite digits for patterns that might encode contact from a universe where math itself is alive. Whether proven or not, the mathematical universe hypothesis forces a profound shift in perspective. It suggests that the search for ultimate reality isn't in telescopes or particle colliders, but in the raw power of human thought. That every time a mathematician scribbles an equation, they might be drafting the blueprint of a cosmos. And if that's true, then the boundaries between discovery and creation, between the imagined and the real, were never really there at all. From the quantum entanglement of parallel worlds to the holographic echoes of higher dimensions, we've journeyed through 25 extraordinary theories that stretch the limits of reality itself. Each one offers a unique lens to view the multiverse, whether it's black holes birthing new cosmos, dark matter as the shadow of another reality, or consciousness itself acting as a bridge between worlds. The inflationary bubble multiverse paints a picture of cosmic froth, while the mathematical universe hypothesis suggests existence is nothing but numbers woven into reality. Some theories, like Brane collisions and cyclic conformal cosmology, rewrite the Big Bang, while others, like Boltzmann branes and time stream ripples, blur the line between perception and existence. What makes these ideas so thrilling isn't just their audacity, it's how they force us to rethink our place in the grand scheme. Are we one universe among infinite copies, or is our reality just a single thread in a vast, interconnected web? Could the anomalies in our experiments, those fleeting faster-than-light particles, those unexplained gravitational waves, be whispers from another dimension? The beauty of the multiverse is that it turns science into the ultimate detective story, where every unexplained phenomenon might be a clue pointing beyond the edges of our cosmic map. Now it's your turn to weigh in. Which of these theories resonates with you most? Is it the elegance of entangled universes, the spine-tingling possibilities of simulated realities, or the raw creativity of fractal cosmos? Drop your thoughts in the comments. Let's geek out over the multiverse together. And if you're hungry for more mind-bending explorations, don't forget to like and subscribe. The universe is stranger than we can imagine, and we're just getting started.